How are you? Hello.
Hello. Good morning.
How are you? Yeah, I've
Fine.
done it.
Fine. So thank you for joining, and I'm so sorry for the problems you are having from your side.
Okay.
All right. So the reason for this meeting is for us to discuss the project that I sent through your partner. Um, I saw a link, a Facebook page about STEM activities in Liberia. So I decided to reach out. And here I have met you. So I am the director of the Pan African Citizen Science E-Lab, and what we do in our organization is astronomy. Okay, astronomy research, and the kind of astronomy research that we do are those that involves ordinary people. Okay, normally astronomy research requires experts in astronomy, but there are other aspects of astronomy that ordinary individuals can contribute to, and we use those activities to promote space science and astronomy in Africa. So one of them is asteroid search. Okay, and the other ones I have some slides to show you all our projects. All right, so okay, let me introduce myself again. My name is Miracle Chibuzo Marcel, and I'm the director of the Pan African Citizen Science A Lab. Our organization is online. Everything we do is online. So our projects do not require buying this, buying that. No, you just use your computer. You don't need a telescope. The images or the equipment you will use are accessed online. So we have our first project. We have asteroid search, asteroid research in Africa, and we have other projects under that 1.0. We have project 2.0, astrophoto visual development. We have 3.0 web telescope, and 4.0 is exoplanet search. I'm going to explain each of these projects. Uh,
Okay, I'm here.
okay, yeah, my computer is a little bit frozen. Just a moment. Just a moment. Let me move it to the next slide. Okay, so under the first project 1.0, we carry out projects on asteroid search. We also do what we call space art. We promote space using space art. Then we have space competitions. So let me explain it. Why do we search for asteroids in the first place? What are these asteroids? And why do we search for asteroids? Now, the Earth, the solar system, which comprises the sun, the planets, and other moving objects within it, was formed about 4.5 billion years ago. So after the formation of the sun, these other things started to form. Those other things that orbit around the sun started to form, including the Earth. So some of them formed planets, okay? But those that were not able to form planets, okay, they remained in chunks. They remained in chunks, okay? We call them debris. So some of those debris can be called asteroids, okay? So they are like rocks. They range in sizes. Some of them can be as big as a little stone. Some of them can be as big as 1 kilometer wide, okay? So, and they are mostly around this region, this red region, okay? So we have others that are orbiting around this Kuiper belt. So, but the most important ones to us are these ones that are here, this asteroid belt region. So, left on their own, they are stable, happily orbiting around the sun. But due to the influence of Jupiter, Jupiter is the biggest planet in our solar system, and it has
Yeah.
gravity. It has more gravity. So, because of the gravity of Jupiter, it influences their orbits. Okay, it influences their orbits. So, so they drift. They change their direction. So sometimes some of them will start to come closer to the orbit of this inner planet here. So imagine that this is Earth and an asteroid just passes right in front of it. So many of them, there are millions of these asteroids, okay? So just imagine asteroid just as Earth is just moving like this, an asteroid just cross it. It is very dangerous. You see that? Or maybe even in heat on Earth, it is very dangerous. Okay? So and these things are very big. Some of them, when they fall to Earth, they burn up in the Earth atmosphere. But for those of them that are up to 100 kilometers wide, they have the force. They have what it takes to destroy a city or even destroy the whole planet altogether. So these are some of the asteroids that have been discovered so far by citizen scientists. So once these asteroids are discovered, they are cataloged, okay, by NASA. They are cataloged by NASA so that we can always know where it is at any moment in time. So that in case if anyone that is at the verge of colliding with our planet, we can use several methods that we have to mitigate it. So that is why we search for these asteroids. So this is what happened about 66 million years ago during the time of dinosaurs. Okay, dinosaurs dominated the earth as of then, just like humans are dominating earth now. They are the most, let me just say, the widest animals of their time, but they didn't have a space program, and unfortunately, asteroid impacted Earth that time and destroyed all of them. All of them were gone. So, of recent, this happened recently. Okay, it happened in Russia in 1908. Look at this place. This place is as big as London. It happened in Russia, but the area is as big as London, and it is a forest area. It's like a forest. So, but the asteroid landed because of the heat of the event. It vaporized all the trees and all the light forms, so you can see it as looking at as a desert. So this is what it can cause. This happened in 2013 in a broad daylight in Russia. An asteroid landed, and thankfully it did not land in a city. It did not land in a city. It landed in a very remote area. So it didn't cause loss of lives, but it the shock wave from the event traveled all the way from where it landed to the nearest city and destroyed so many properties worth billions of dollars. So you can see how it can happen all the time. It happens all the time. Uh, this happened recently. Okay, look at this. This is a simulation. Let me show you. Look at the simulation. You can see it landed. You can see how bright it is. So this happens every part of the world. It has happened in Sudan. It has happened in Libya. It has happened in Ghana. It happens every time. So if it happens in your country, and you have the knowledge of this asteroid, you could, help to advise the government on what it is, because so many people don't understand what it is. They attach some mystery to it. They understand. They attach some of their mysterious beliefs to it. You know, saying it is the end of the world, this and that. So that is why, we need to spread knowledge of science. Then a man was at his home in 2020 from Indonesia. All of a sudden, an asteroid landed and penetrated through his roof and penetrated into the ground. So he came out. He was very surprised at what happened, but he dug it up and sold it for about $2.5 million. He became a millionaire overnight. Some of these asteroids, not all of them, but some of them, contain rare earth minerals like iridium. And this happened in 2022. Okay, look at the orbits of the solar system, the planet in our solar system. This asteroid landed. Guess what? It was just 2 hours before it landed that we spotted it. Just 2 hours. But luckily for us as humans, it landed into the sea. The Earth is 70% water. The Earth is 70% water. So the chances of falling into the land was slim, but it's not something you have to, you know, count on the probability. You have to always be very careful. Just 2 hours before it landed, that we spotted it. So just imagine that it landed in a city. Just imagine that it landed in a city. It would have been a different story by now. This happened last year. Last year. So it is not something that we play with. Now, because of the frequent impact or the danger that we face as humans, there has been a number of programs, a number of satellites, space satellites and ground-based telescope constantly monitoring the sky, you know, observing these asteroids and taking images and analyzing those images to spot those asteroids. So these are some of those surveys, some of those satellites. The data that we work with are coming from the pen stars. Okay, the data that we work with are coming from the pen stars. So here is the pen stars. Here is the pen stars telescope. It is located at the University of Hawaii in the United States of America. So every now and then it scans the sky, monitoring these asteroids to know their trajectory. It is not always those ones that are coming to Earth, but all the asteroids in space altogether, because we need to keep track of their movement, because those ones that have left the asteroid belt, they change their orbit every now and then. Okay, maybe last year it might it might not be headed towards Earth, but this year it might just change direction and face Earth, and it becomes dangerous. That is why we are constantly monitoring these asteroids. So after collecting the data, they are saying this. By the way, this telescope is among the busiest and the biggest. It collects the most data. Okay, it collects data in the commercial level. Other ones that I mentioned here collects data in very minute level. So after collecting the data are sent to these people, the Isaac people, International Astronomical Search Collaboration. Now, this organization is responsible for distributing it to different schools and organizations around the world. Okay, so not only for us, all the countries, okay, these people have been in existence since 2006. So they have been, well, most people that participate in these programs are mostly Europeans, Americans, Japanese. So we discovered it in 2020, and we decided to spread it in Africa. So we have been around for the past 3 years, and we are registered with them. So this is the software that we use. We are going to train you on how to use this software to search for asteroids. This is called astrometrical software. So look at it. You see these other dark spots? These are the background stars. And you have this one that is moving. This is the asteroid. So this is how we detect asteroids. This one now has been discovered by other people. Okay. So this is how we do that. Then it's just part of the programs, our campaigns. We have been engaging with mostly university, space agencies, and astronomy organizations and other STEM organizations. So across Africa. So we have reached up to 40 countries in Africa, about 40 countries in Africa, and most of them have discovered asteroids. So these are some of the countries that we have. We have active groups that are searching for asteroids and participating in other of our programs. So this is our timetable. Okay, this is our timetable for the new academic year. The new academic year started on August 10. Okay, this one has gone. So we have these till December, and this is for 2024. So we have a lot of opportunity in our organization to include your team. And here are the requirements for participation. So you need a computer operating system, so a Windows operating system. It could be that Windows 7 all the way to Windows 11. You need a good internet connection. Then time commitment is about four hours per week. It is not something that will consume your time every day. So if you are very busy in your office or at school, maybe you are wondering why, maybe if you cannot participate in this program, you know, it's a program that can you can do without interfering in your work. You can do it at your pace. You need a minimum of about 3 to 5 people, sorry, 3 persons to form a group. 3 persons to form a group. I mean, we want teachers first, teachers that will disseminate the program to the country. We want those people first so that when they learn it, they can spread it. Then you also need passion for space and astronomy and discovery. So these are some of the discoveries that we have made so far. We've started this program in 2020. So getting to 3 years right now, and we have made up to 27 discoveries of asteroids. And one thing about this asteroid is that in the future you get to name it. So for now, it's going to bear this number. It is going to bear this number, the provisional number. But in the next 5 to 8 years, they're going to name the asteroid. So it is a very wonderful program. So you're not just doing it for NASA. You're not doing it for NASA. You are doing it for yourself and also to boost space science education and outreach in your country. So then we have another one. This is the end of the asteroid search. Then we have space competitions. We are working with this organization to spread astronomy competitions in Africa, the International Astronomy and Astrophysics Competition. Their program runs every year starting from February to June. So this is their website, this is their poster. So we have two categories. We have the junior under 18 and the youth above 18. And here are the 3 stages. We have the qualification round, the pre-final round, and the final round. So by the end of the program on June, the students that are participating might make it in the first or in the second or in the third. So it had different prizes. And we also sponsor some of our African students who are not able to cover the fee because after the qualification rounds, they are required to pay a fee of $9. So depending on our budget, we sponsor them so that because we want more Africans to participate in astronomy related activities. So this one is mostly for teachers in the secondary school and in the primary school. So here we inspire, we tell the teachers to tell the students to draw anything they can imagine about space. Anything they can imagine about space. So these are some of the arts we've collected from pupils and students in the past. So the age to participate in all ages below 16. And the organization responsible is Space for Art Foundation. This lady here is the one in charge. She's an astronaut, but she's a retired astronaut. Okay, astronauts are those people that travel to space for scientific research. So she's spending the rest of her life going around the world inspiring children to pursue careers in STEM. So she's using her field space to inspire children. And when those arts are collected, they are used to build this kind of spacesuit. So this spacesuit contains artwork of children from all around the world. And sometimes the spacesuit is flown to the International Space Station. Look at the International Space Station here. And this is an astronaut wearing it. This is the International Space Station. In our work, I'm going to show you how to detect it here from your country. It goes around the Earth every 90 minutes, and it is like a star, but you will not even know it is International Space Station. So it's as big as two stadium. Then we have our second project. Our second project is Pascal Project 2.0. Here we teach people how to process images from space, gotten from this telescope. We use images gotten from this telescope. This is the Hubble Space Telescope. This is the Webb Space Telescopes, and this is the Los Commons Observatory. These are among the best telescopes you can ever uh, use in the world. And we're going to teach students and space scientists or space enthusiasts from your country how to process images of space. But I before I move on, before I rush it, I want you to understand and appreciate the meaning of image processing. Look at my image here. This is me. Look at this is a camera. So I used my smartphone, okay, to take a picture of myself. And when I used it, I didn't have to process it further. Okay, it appeared the way it appeared as I took it. So right here you can see I'm wearing a I'm wearing a red tie, I'm wearing a white shirt, and this is my complexion, this is my hair, this is the whiteboard behind me, this is a camera. So both these two technologies can take my picture and I don't need to process it further. So because these two technologies have what we call color CCDs. So when you take a picture, you don't need to process them further. But the kind of camera we use to take images of space are not like this. We use a special camera called telescopes. So when you take an image of the space of deep space with your telescope, this is what you're going to get. Black and white. Sometimes completely dark. However, all the information you have taken about the object that you want is buried in this file. This file is called fit file. It is buried inside here. So it is your responsibility as an astronomer enthusiast or a professional astronomer to use special computer programs to extract all the images, sorry, all the information to produce vibrant images or visuals. And when you do that, you're going to produce beautiful images like this. So this is images of space that you usually see from the internet. When they are taken, they don't appear like this, they appear like this. So it is your job, which we will teach you, to turn it from black and white to beautiful colors like this. Then the third project is Webb Telescope for Observation and Research. Okay, if you are an independent researcher like me, I mean, if you're not a student or and you want to carry out research in astronomy, we have our telescope time with the Los Crumbs Observatory. Okay, Los Crumbs Observatory (LCO) is a remote telescope. You can operate it from the comfort of your home or your office or your workplace. So we use it for research, and we have a research team, and we are currently carrying out research with it. Okay, so that is our third project, and this research is published. And the fourth project is exoplanet search. This is our latest project. Here we search for planets orbiting other stars. So exoplanets are planets that are orbiting other stars. So when a planet is transiting its whole star, the brightness of that star goes down, and when the planet goes out, it comes back again. So this is called a light curve. So this is what you are going to be producing. You're going to be producing this light curve. And we have a separate training for that. and we are planning to start it this month. So if your team succeed in the asteroid search, we go straight to this. Okay. So um, on the line, if you succeed in our project, we also donate telescopes from the Office of Astronomy for Outreach. So that is the end of my presentation.